Let's look at range and standard deviation. For the book Youth Ministry That Transforms, Merton Strawman, Karen Jones, and Dave Ron surveyed 2,130 youth pastors. In order to make it easier to analyze data, they say they converted scores to standard scores with mean 50 and standard deviation 10. We know what a mean is. What is a standard deviation? That's what we'll learn about in this video. Here are the heights in inches of the 13 men on the roster of the Chicago Bulls NBA team. 72, 81, 79, 81, 74, 81, 76, 82, 82, 83, 75, 81, 79 inches. Here are the heights in inches of the 15 men on the roster of the Miami Heat NBA team. 77, 82, 80, 82, 83, 74, 74, 74, 84, 80, 80, 80, 82, 84, 76. Is there more variation in the heights of the men on the Bulls or in the heights of the men on the Heat? Which is more spread out? There are different measures of variation. Sometimes we call these measures of dispersion. The range is the largest number in the set minus the smallest number in the set. In other words, it's the maximum minus the minimum. For the Chicago Bulls heights, the tallest man is 83 inches tall, the shortest man is 72 inches tall, so the range is 83 minus 72, which is 11 inches. Similarly, for the Miami Heat, the range is going to be 84 minus 74, in other words, 10 inches. So the Bulls' range is 11 inches, the Heat's range is 10 inches. Based on the range, there appears to be about as much variation among the Bulls and among the Heat. Besides the range, another measure of variation, measure of dispersion, is the standard deviation. This is far more common than the range. First, I'll show you how to calculate it by hand, and then I'll show you how to do it on the TI. I am not going to hold you accountable to know how to do it by hand. You'll always be able to do it using the standard deviation feature in the TI. So suppose we have a sample of n numbers, x1, x2, x3, ... all the way up to x sub n, with mean x bar. Recall that x bar is the mean of a sample. The sample standard deviation is s equals square root of sigma x minus x bar squared over n minus 1. That Greek letter capital sigma is often used to represent sum. So we have the square root of the sum of x minus x bar squared over n minus 1. Okay, the formula for the standard deviation of a population is slightly different. Here's the formula for the standard deviation of a sample. The population standard deviation is square root of the sum of x minus mu squared over n. We use that symbol for the population standard deviation, which is the lowercase form of the Greek letter sigma. So we have sigma equals the square root of sum of x minus mu squared over n. Again, what's the difference between a sample and a population? Just as review, a population includes everyone, a sample includes just some, not everyone. The data set we're going to look at includes only some NBA players, so we have a sample, not a population. Is there more variation on the heights of the men in the NBA or on the heights of the women in the WNBA? Which is more spread out? Which has the greater standard deviation? Here are the heights in inches of the 28 randomly chosen men from the NBA. 79 inches, 83, 77, 77, 78, blah, 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 all the way up to 83 inches. Here are the heights in inches of 28 randomly chosen women from the WNBA. 76 inches, 67, 78, blah, 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 all the way up to 74. These are samples, so we'll use the formula for sample standard deviation. Let's find the sample standard deviation among men. We'll do it by hand. And again, I'm not going to hold you accountable to know how to do it this way. Sample standard deviation is s. It's the square root of the sum of x minus x bar squared over n minus 1. First, we'll find the sample mean, x bar. As we've seen before, to find the mean of a set of values, we add up the values and divide by the number of values. So the sample mean is going to be x bar. It's x1 plus x2 plus x3 plus ... plus x sub n all over n. So again, here are the heights of the 28 randomly chosen men from the NBA. The sample mean is going to be x bar, which is 79, plus 83, plus 77, plus 77, plus 78, plus blah, 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 plus 83 divided by 28. That's 2229 divided by 28, which is 79.6. So that is the sample mean, the mean of the sample. The sample standard deviation is s equals the square root of the sum of x minus x bar squared over n minus 1. X bar we just saw is 79.6. Gosh, what do we mean by the sum of x minus x bar? Well, again, here are the heights of the 28 randomly chosen men. So the sum of x minus x bar is going to be, well, first value of x we'll look at is 79. So we have 79 minus 79.6 squared. 79.6 is x bar, the sample mean, plus 83 minus 79.6 squared, that's the height of the second man, plus 77 minus 79.6 squared, 77 is the height of the third man, etc., all the way up to 83 minus 79.6 squared, the height of that last man. And that turns out to be 236.68. So let's plug that in above. Look above. So we get s equals the square root of 236.68 over 28 minus 1. Again, that sum is 236.68, as we just saw, and n in this case is the number of values, that's 28. So that's square root of 236.68 over 27, which is roughly 2.96. Okay, let's find the sample standard deviation among the women. Let's do it on the TI. So again, here are the heights of 28 randomly chosen women from the WNBA. This is a sample, so we'll find the sample standard deviation. Okay, here's how we use the TI to find the sample standard deviation. And let me bring up the TI. Okay, so first we're going to turn this thing on, and then we press Stat, which is here. And then under Edit, choose Edit. So in this case, we can just press Enter. Okay, now we type in the data and press Enter after each one. So let's see, we have 76, Enter, 67, 78. Oh man, what is more exciting than watching your teacher enter data on the TI? This is a thrill a minute. 72, 72, 72 again, 77. Oh, almost there, quarter of the way. 72, 70, 68, 70, 74, 72, 75. Okay, halfway there. 75, 74, 69. That's how tall I am. 67, 72, 76, 74, 69, 70, 'Thrill a minute here. 74, 76, 71, 72, 74. Okay, now we're done with that. So now we press quit. That's second, and then mode. Okay, now we press stat. And under calc, so we need to use the right arrow to get there. Under calc, we choose one variable stats. So we'll just press enter. Okay, so now press enter. So what we want is S sub x. See? S sub x is the sample mean. That's 2.9743. If this were a population, we would use this. We would use sigma sub x, which is 2.92. But again, these 28 values are not a population. They're just a sample. So in this case, what we want is 2.97. So S sub x is 2.97. Okay, S again is the sample standard deviation. Sigma is the population standard deviation. We want S. This is a sample, so we want the sample standard deviation, which is S equals 2.97. Now recall for the men, the sample standard deviation was S equals 2.96, so they are roughly the same.